Usually we would like to identify which one of these would have the better elementary antiderivative, and we find that they both do. So the general formula that we plug this into in integration by parts is u times v minus the integral of v du. In each case, we can choose either one to be u or v because they both come out to simple elementary antiderivatives as mentioned before. So we choose our u to be e to the x and our dv to be sine of x dx. Our v then becomes cosine of x, and our du is then e to the x dx. We then plug it directly into the formula, and we forgot the negative in the cosine. So we plug it back into our formula and we find our u is e to the x, so the integral of e to the x sine of x dx is equal to u e to the x times v, which is minus cosine of x, minus the integral of v, which is minus cosine of x, and du, which is e to the x dx. We bring out the e to the x because of the fact that if we put it after the cosine, we may confuse the fact that x times e to the x, or some confusion might happen. So in order to just gain some clarity, we bring out the e to the x. In order to simplify this, we can combine the negative signs and we get the integral of e to the x sine of x dx is equal to negative e to the x cosine of x plus the derivative of cos e to the x cosine of x dx. Here's where we begin to see where the boomerang starts to make a little more sense, because we still have an integration sign on the right hand side of the product. So we want to figure out a way to make it much more simpler so we don't have an integration sign that is in our way. In order to do this, we do the same part that we did above and we break the integral down, still reminding ourselves that this is still a part of the product. So we move on to say that the integral of e to the x sine of x dx is equal to negative e to the x cosine of x plus the integral of e to the x cosine of x dx. And we focus on this aspect of it, of the product, in order to break it down. So we can assign once again e to the x to be our u. Our dv is equal to cosine of x dx. Our v then becomes sine of x, and our du is once again e to the x dx. Lo and behold, we find our simple antiderivative of cosine to give us back a sign that we began with. So we plug this back into the original formula that I gave, which is u times v minus the integral of v du. So we take our u is equal to e to the x times v, which is sine of x, minus the integral of v sine of x du e to the x dx. And as I mentioned before, we should take it out and simplify it to be, again, e to the x sine of x minus the integral of e to the x sine of x dx. And as we combine this, we go back and make sure that we combine it to the first part of the problem. So we get the integral of e to the x sine of x dx is equal to this part, then comes back down to the final product, which is negative e to the x cosine of x minus e to the x sine of x minus the integral of e to the x sine of x dx. And my partner Sam will begin to explain the last half of our problem.